And for today, we're going to continue cover the Python basics about conditional statements and also some basic looping dictionary. Okay, it's from here. Before we get into that, I want to quickly go over some of the common mistakes in the lab assignments. I finished all the grading of the lab assignments. So if you get any points deducted, that means something's wrong or something I'm missing. And one of the most common one is the open in collab, and the link is not working. The link is private. It happens, and the link is broken. I'm going to show you how to avoid it because you don't want to load up pretty basic common stuff. You don't want to be losing the points. Yes? Yes. So that's the problem. So that's why I'm going to go through that, all the common mistakes. Kind of general procedure. But once you're very familiar, you should be able to figure it out very, very quickly. So first it is to add a notebook. Second is to add the base, right? And the reason for that, if you are very quick, you can add the notebook and the base at the same time and very easily. Once you have some example. So let me show you here, right? I have all these, right? So if you click any notebook, I can just open here and it should take you to the Google Colab directly without login. So anytime after you finish this, after you add something, the link is supposed to be a public accessible link. One way you can figure out is right click and then open link in incognito window. If this one doesn't open, it requires login, it's wrong. Okay, you see here, it's perfect, there's no login required. And some of you is like doing it incorrectly. I think you save the notebook to your Google Drive and then trying to use the share link and then use the private link. That one is incorrect. So don't do that. I'm going to show you how to do it quickly. So for example, let me open my package, my repo here, and quickly, for example, I want to add a new notebook. So let me show you how to do that. I'm going to go to maybe my examples here, right? So what I need to do, just right click, and then we can say demo. So IPYNB, for examtle, or lab 4, lab 5, whatever. Lab 4 is already released, so it will be very much similar. So for your lab assignment, you need to do something like this. And from here, you can start writing text, markdown, whatever, right? I can just write a simple one. Okay. Hello, demo, something like that. So usually here, if you know, you can usually press A on your keyboard, or you can just come here, add a new markdown, and then you can drag the markdown above. Sometimes you might need to drag it. So you want to have the markdown at the beginning. So this is where you put the base. And usually, if you already have some example, you can just go to the previous one in here. You need to find a base. So I'm going to find a previous one, for example, from my anyway, maybe like this, easier. I don't want to add a link right now because I don't know where the link is going to be. So what I can do here is just like create an empty markdown and also a Python code block in here, whatever. And then just simply push this to GitHub. You can create a new branch if you want. I'm just going to say add demo notebook. And just sync changes. Okay, it's done. So now I'm going to go to my find me here, and you will see I'm going to undo my docs folder. Then under the examples, this one, right? So this is where you get the link, okay? Once you come to this page, where you figure out the link is to again come here. It's very difficult to see github.com or something. Just type to collab, okay? And it's redirect. You can just Control A, Control C. You can use this link. It's fine. Or you can just try it out to add to collab after GitHub and then press enter. It should redirect you to the link. And this is the link that you need to copy. This is the link that's redirect. If you accidentally save this one, for example, to your drive, of course, you need to log in. Log in here. And after you log in, if you try to run it, and later on, if you try to, for example, click this save, share, no, this is still under my account. Oops. So if you save this one to a computer, then It's not the incorrect, this is the incorrect link. So save a copy to my drive, and the link is going to change. So if you copy this one and then you put it on your base, it's wrong. Because if you open this one and then you paste, it usually doesn't work. You need to log in unless you click this share and then you change this setting to like anyone, the public link, and then you do it. But this is not the recommended way because the URL here, you see a random string here. And it's not good because people don't know where it comes from. So it's better to use this link, this one. So again, any notebook on GitHub, just add to collab and then redirect, copy that link. So for example, this is the one that you should get. And then now you can come back to the notebook in here. You can start modifying it. And just to be safe, I'm going to pull changes again, make sure that I'm synchronized with the main repo. And then you can come to your any other notebook. So for the previous lab assignment, you already have something similar. So I'm going to go to any notebook that I have, and I'm going to find this base at the beginning. There should be a code block showing you this base, right? Just double click. Only just copy this link, come back to the new notebook, paste it. So if you're really good, I can actually come in here, your name, everything else remain the same, except you'll be something like this, right? So this is a Python directory, this is notebook. I can write examples and then slash and then blah, blah, something like that. But the best way to avoid typo is just to come here, like I said, since your notebook is already available on GitHub, you can either copy this one and then come to here and replace it. We usually do it like this, copy, paste, and then I just come here. I don't need to use it. I just to collect. We guarantee it usually works. Okay, this is, and I have to shift enter. Now if I click this link, take a look. It should take you to this, redirect you to the Google Colab link. If you want, I can also use this direct link. So I can Control C. I can come here. I can press. So basically this one or this one. Either one works, okay? And then Control Enter, Control S, then I'm done. So you can test it, right click. Here you cannot right click. You need to open the notebook, take it to here. Make sure that you open the link, try it out, because right now it's not there yet because I haven't pushed it. Okay, so this is one way. Make sure you copy the link and then just open incognito mode. Just try it out. Make sure it doesn't require login. If it requires the wrong link. Next, for the lab 4, so I also ask you to add this one to your website so that it can show up on the website. So for example, here, I'm going to go to Geospatial, right? I have the lab 4 here. So you have to have something similar. For example, your lab 4, when you click, you're going to have something in here. But all your lab 4 should also have the output. You're going to execute it. I'm going to see the output. So if your notebook just empty, it's not right. You need to execute and then show the output. So what you can do here, for example, you're going to have this one, assume, right? I can run this one and then execute it. So you're going to have the output somewhere. My output will probably be cleaned up. Maybe not. So here, and then you can say 1 plus 2, blah, blah, something like that. Okay, so assume you're done with the assignment. So the next step important, how to add that one to your table of contents. So you can come to here, the mkdocs.yml, this file under your root directory, under your package root directory. So this one controls how the table content, your navigation going to look like. Right now here on the left side, so you should add your notebook to the navigation. So for example, I added another notebook under the examples directory. I can add that one directly to here. So it's pretty simple. Just come to the Visual Studio Code. You can create a new section if you like. You can create another one like just like I'm doing here, labs, whatever. And so for me, it's under the examples folder. I can do it like this. So hover your mouse to the last line within this section. And then at the end, just Control C, Control V, okay? You don't need to hit enter, just Control C, Control V. It should add a new line under there. And now you just figure out the name. So my name is demo.ipynb. So what I'm going to do here is just demo.ipynb. Control S and done, right? So I have the notebook. I have the open in collab link. And I also have that one is going to show up on the table, the navigation. This is pretty much what you need to do for all your feature lab assignments. Whenever you have any notebook, you want to add that. So when users go to the website, they can see the source code, they can see the output. If they want to try it out, you can click the link, open the base, and then go to collab, and then they can log in to try things interactively. So here I can just write add demo notebook to table content. Control enter and sync. Hopefully after a minute or two, you should have everything up and running. Are we clear now? So make sure you, if I ask you to submit a link, make sure you right click the link and open incognito mode. Make sure everything is working. Otherwise, you're going to take points off because I don't look into detail of everything. But at least for those links, I will try to open, see what's inside. And anything goes wrong, then you fix it. So usually you should wait until, oops, okay, something is wrong, pre-commit, and blah, blah. No, okay, because I decided to remove all the the output. So right now it's not working. So for me, I can. This is something I edit new stuff I added. So it's not available in your code block. So basically, I have this one here. We config. Let me quickly fix it. Okay. You don't need to do this. Okay. I haven't covered this one. This is to make your repo more clean, so you don't have a lot of stuff. So you can basically like check before you commit. So I'm gonna pip install I'm just gonna fix the error, so you don't have to do that. But it's good once your package become popular, you want to make it standardized. So when people push the stuff, you will do the automatic formatting so that your package is always clean. There's no last files, there's no typo, there's nothing. It's pretty good. So I only added this one last week to all my packages. Now it's much better. So meet install, and it's going to check all the error. It's going to remove the stuff. So meet, and it's going to run all files. So what it's going to do is to check all the notebooks, all the files, see if there's any error, and it's going to fix all the stuff. And you fix the errors before you push to GitHub, push into basically before you commit changes. Kind of like the sanity check before you do something, before you're trying to destroy something, right? It's avoid some accidental errors. The first time it might be a little bit slow, but after that it should be pretty fast. So the file is under here. If you want, you can copy this file. You put in here. It's going to do the formatting, check all the file, make sure all your files are correct, and then no any files larger than 500 KB, and also going to strip all the output from all your notebooks. Because if you have a notebook running and then producing maps, all kind of data, your notebook will be pretty big. So you should avoid making your repo super big. You should try to make it pretty small, because when you try to clone the repository, you don't want to have a repository that's like huge. If I go to my downloads directory, you can take a look. Right now it's pretty small because most of those are pretty small files. So downloads this. So you want to check, for example, under my documents folder, and within, for example, here Python. You see, most of those are pretty small. But if you have large files in there, it's going to be big, megabyte. That's no good, because all the output are kind of a temporary stuff. You don't want to make it long. Anyway, if it doesn't work, we can try again later. So this is basically the general workflow: how to add a notebook, how to add a base, and how to check the link, and how to make sure it showed up on the web page. So it should be. Okay, it's taking too long. Let me clear the output. One. Clear my output. That. Yeah. here. No. Okay. And for lab 4, there are a lot of questions, but those are pretty basic stuff. You should be able to figure it out. If you have questions, just ask ChatGPT. So ChatGPT will help you get all the answers. There's nothing fancy in stuff. So, but I suggest you take some time. Don't be lazy. Don't try to ask ChatGPT for all the questions. Never learn. If you can finish all the stuff without looking at any resources, that means you are really good. If you have to keep checking internet, ChatGPT, it's not your stuff. I know it can get done, but some of the basic stuff you need to understand before you can do some complicated stuff. But it's fine at the beginning. You need to check and ask for help. But if you still cannot figure it out, let me know. I can help you. I can cover a little bit more in depth in class. And so after this one is done, I'm going to show you how to do debugging. Especially if the beginner, you write a bunch of code. You don't really know how is actually Python is running. So debugging can be particularly useful. You're doing like looping, conditional statements. You want to see the workflow, how actually the Python executing the source code. Oh, this is anyway, it's just too long. Let me directly go to the number 5. Okay, notebook number 5. So I'm gonna start from here, and we're gonna do the debugging first. So make sure that you know how to do debugging. Super important if you don't know how the program is running, because it's going running from the beginning to the end. But if you have any conditional statements, you have any looping, it's going to loop through that. So here, the first example we're going to use, start the kernel. We already covered the for loop last time, but here this is another example. So once you come here, right, this is the first code block. So pay attention. This is where you start doing the debugging, right? We have a variable defining cars, and then we're going to do the looping. And if the car is equal to BMW, you want to print out the uppercase. Else, so if and condition. So if else, you don't necessarily have to have else statement. You can just have if statement. It's fine. You can have if, you can have if, else if, else if, else if, and then else. So those are kind of multiple scenarios. So here, pay attention. This is where when I hover my mouse on this code block, do you see a red dot over there? This is called breakpoints. Breakpoint means, so if I don't ask it for you, if I just click this execute button here, take a look. Like it just execute all the output. It doesn't wait for you to give instructions. And sometimes it can be challenging to figure out what's wrong because you have a long code block and you don't know where the problem comes from. So here, this is where you can really do the debugging. So you can hover your mouse to where the line, where you want to start looking into that. You suspect something is wrong within this code block. So I'm going to go to maybe here, the first one. But the first one usually is, it should be fine. Probably no problem, but probably in here, in the looping. So I'm going to start under the, in this line here, click this red dot, and then it's going to stop there. Then in here, click this drop down arrow, and you should see this one, debug cell. So debug cell, that means we want to start doing the debugging, okay? I'm going to find the bug. Doesn't necessarily have the bug. Debug means just going to look into that. So click this one, and after a couple seconds, you should see something here pop up. Mine is at the lower left corner, lower left. Maybe push it to, you can move it somewhere else. So it's at the top, okay? So for me, I can move it a little bit here at the top. So you have these couple icons in here. This one is called the, what's it called? Continue, skip, and then step into, step out, and also refresh. And the last one here is just disconnect. So right now means we're stuck debugging. So pay attention to here, right? there's a highlight, light yellow in here. And so what this one is doing is stop here, stop in this line. And keep in mind, this line has executed. Yeah, this line is already executed. Maybe let me do this. Okay, let me stop it, or let me run out this one. Show you one more time. Like this. Here output. Let me put this one here just to be better explain what it's doing. So I want to put in the first line, and then I'm going to start debugging. So I want to start from the very beginning. So when I put my lines in here, oh, this is something is not supposed to have the variable. So get the output, restart the kernel, then start the debugging again, debug the cell. It should stop in the first line, so it don't go to the next line. So the car variable should not stored up. Okay, yeah. So right now it's done. So this is pretty clean. And so you're going to stop in the first line. Pay attention, this line is not executed yet. So pay attention to the left side here. It's called variables, local. So this one is going to show you all the variables. So Python programming, basically everything is somehow stored in the memory. It's basically a reference. So right now we are stopping in the first line. You can click this one. This button, the down arrow, it basically says step into. So you basically going to step line by line. So if you click this one and then pay attention to the left to see what is going to change. So if I click this one, and do you notice any changes? Edit the list like cars. So right now, basically, this is the variable that we just executed. So it's going to have something in the memory. If you click, you should be able to see what's this one. It's the list variable, the indexing 1, 2, 3, 4. Right? Next, we're going to do the looping. So see how this one is executing. Okay. This is super useful to figure out basically the logical flow of the programming. So we have 4 cars. We're going to loop through, and right now, right, as I mentioned in the past, this variable doesn't matter. It's just a placeholder. It can be anything. And pay attention to the left. Do you see the car variable there? It's cars. There's no car yet, okay? So if I execute this one, press this one again. Pay attention. Do you see that? It comes up. So now, because it's doing the looping, so the first time you're looping through the list, so the first time index is this one. So it's first time the car is going to equal to Audi. And this is the conditional statement. So in Python, the equal is double equal, okay? If only one equal sign is assignment, it's not comparison. If you want to compare if two stuff are equal or not, it's using double equal sign, okay? So here it says, if car is equal to BMW, then you uppercase. So is Audi equal to BMW? No? So this is see where it's going, right? I'm going to press again, see how it's going to jump through. See, it go to the next one. It doesn't execute this one because it doesn't equal. So it's not doesn't meet this requirement. You don't need to execute. It doesn't matter. So it's going to go to the else and then execute this one, right? And then pay attention. If I run again, see where it is going back. Make sense? So we're going to print out the first one. It's only a title case. And similarly, it's going to run this one again. Pay attention to the left. Right? I haven't executed this line yet, but once I run it, you see, right now it becomes BMW, right? And is BMW because equal to BMW? Yes. And see where it's going? It prints out the BMW, right? And after I'm done, if you execute again, okay, it goes back. So basically, it's like a circle. It's a feedback loop. So now if I come back again, see this one, Subaru, right? It's not equal. Then it's going to jump to the else, and then go back to the cars. Last one, Toyota, no, else. And last one. So you see here, the last variable is still in the memory. It's called Toyota. And if you recall the example that I gave last time, when you say the looping and then print the last line, why is here? Because that variable is in the memory. That's why you can still use it. So if you run this one again, done. So now we finish the program. But I can certainly have something in here. Let me show you. Sometimes if you have too many things, you have at least like 100. You just want to check something and then you skip to the rest. So I can write another one here. I can say print and then done. Okay, you can do the same thing, right? I can do the debugging cell again, debug the cell, and we're going to run through that, right, one by one, and equal to BMW. And you can take a look at this one, right? So the second one is BMW. Okay, it prints out, and then okay, I'm done. I check the BMW, it works as expected, so I don't need to check again. Then you can either click this one here, continue. It's going to continue to the next breakpoint. So I can come here, I can press another breakpoint here. Then the program is going to skip all the looping and then directly go to this line. So pay attention, right? I click continue. See, comes to this line. So you can skip if you have like another 100 items. After that, fine. I can continue again. Then it's going to stop. It's finished all the. And you want to see the line printed here. Done. Make sense? So this is super useful if you want to figure out how it's actually going. So particularly interesting to see program deal with those conditional statements and also all the looping. And I can change it, right? So here, for example, if car equal to if I do this, exclamation equal means not equal. Okay. So if I do this one, right, what's going to happen? So I can debug again, right? It's pretty unexpected. So right now, pay attention to this, right? I'm going to say for cars in cars. If I click this button, where it's going? Yeah, it's going to come here. And where it's going to go? Huh? If not equal to BMW, so it's not equal, so it's going to print the uppercase. Second one, where it's going to go? Else. Huh? And you can just, so you can change, you can do all kinds of stuff. So this is how you, for example, if somebody, like you design a program, you have a website, you want to allow users to log in. So if you use login, okay, is this username equal to this? And then you allow to log in. Is this like illegal users? You don't allow them to log in. So you can check your database. So I can do it like in here. Let me show you. Let me disconnect this one. I can do something like this. Okay, and say if yeah, BMW in cars, if something in something, it's going to figure out it's in the list or not. Okay, so if Subaru in cars, yes, print out Subaru is in the list. And if you want, you can just, if you just click, it's going to run. Yeah, it's in the list. But how about this? Right? You can uppercase. Is it in the list? No, not going to print out anything. But I can do it here, right? You can allow the user to do something like this, something dot lower. Yes or no? Yes. So you can apply. This is where you can do it, right? I can place a breakpoint here, and you can actually figure out whether it's running or not. Sometimes if you have no idea, is this line executing or not, you just place a breakpoint. And then if the breakpoint is the line goes through that is executed, otherwise it's not. So this is basically how you do the debugging. Again, try to utilize that, especially if you're unsure why it is printing this result, why not the other one. This is called debugging. Super useful. You can do the same thing for a Python script. Right now, we're using notebook. You can do the same thing for here. So I can maybe quickly show you. For example, I can create maybe a script here, txt .ipy, .py, okay. And let me undo the change. Here I can do the same thing. Copy here, come to this notebook, and this is different because you still have the break line, but there's no the execution button. This one here for notebook, for Python, is coming to this menu here, run, and then run debugging. Okay, so it's just a different location. So this one, start debugging, you can press F5, or you can click this one, run, and then you need to select Python debugger. Okay, click this one, and then select Python file. Here, because you need to select also which interpreter you're going to use. I'm going to use this under geo environment. So S. This usually, if you have a Python file, let me remove it. What? If you have a Python file, you want to go here. Sometimes it's usually at the bottom here, showing you where does it come from. So I'm going to check this one, and then go to run, start debugging, Python debugger. Might take some time. So you're going to load up here, and it's going to start the terminal. Then you should have something similar showing up at the top that allows you to navigate through. We will use this one a little bit more when we start developing the package. Right now, mostly just Python stuff. You see? Now it's the same thing. You have this one. You also have things on the left. You want to also have the output. So the printing earlier in the notebook is printed out beneath the code cell. This one is printed here. So I can run through it, print it out. See? Here, and it's done. It's finished. This is how you debug Python script compared to debug Jupyter Notebook. Questions? All right, it's a useful tool. So next is about the conditional statements. Again, equal sign, one equal sign is assignment. So it's running from the right to the left. So we have this content assigned to a variable. Conditional statement here is from the left to the right. So if this car equal to this one, yes or no, different from the previous one, right? And case sensitive, so uppercase, lowercase. If you really want to compare, for example, car equal to Audi, this one is false. But if I do this one, the car dot lower equal true or false, right? Lower. So this is where you design a program, you allow the user to enter the username, email, whatever, right? Usually it's case insensitive. So whenever the variable that you grab, you want to apply a lower function. If you save all the stuff in your program is lowercase or uppercase, either way, then you can do it. So, but password is case sensitive. Username usually is not case sensitive. This kind of more like the convention if you want to do something like that. And you can print out, you can check equal, non-equal, exclamation equal, greater than, less than, greater or less or equal than. So those are pretty simple mathematical operations, how you compare the numbers. And also need to keep in mind, you can only compare number to numbers. You can also compare string to string, but don't compare string to number because they are different, right? So in here, I can say age equal to 40, okay? And I can also have another variable, age2 equal to 40 as well. Okay, are these two the same? You can say age equal to age2, true or false? False, not the same. Because you cannot compare. One is a number, the other one is string. But how about this? True or false? True. Because you can convert. But if you have some other characters inside cannot be converted to number, then you cannot. Okay. And also I can do, I say A equal to AB, okay, B equal to CD, okay, and I will say A equal to B, true or false? False. And I will say, can I say A less than B? Yes or no? May I not say safely? So this is kind of like tricky because when you store those characters in computer, it's using the so-called kind of like ASCII. Basically, there's a sequence. So CD comes after AB. But it's like computer when you compare the strings. This one is actually true. But how about this? I would say A, uppercase A and lowercase a. Probably true or false? Might be surprised. So all the uppercase comes first and lowercase. So all the uppercase characters in the keyboard it actually is stored before. So any uppercase is lower than lowercase. And then I can do something like this. You see if it matters or not. Right? A less than B? Yes or no? It's true. It only counts the first one. So let me show here. Yes. Hmm? It's just like, for example, your last name. Like, for example, last name, like alphabetically. So let me ask ChatGPT, see what's the answer. Right? So in Python, why A is smaller than A. See if it understands what I'm talking about. But you can compare, right? Why is like A in Python when comparing strings, the comparison is based on ASCII value, right? And in the value A is 65, value of lowercase a is 97. Yeah. Yeah, so everything stored in the memory has some kind of values in there. So ASCII mod uppercase A is 65, this is 97. So that's why you can compare. But this is computer, right? I don't know why they did it, but you need to be careful about this. You can actually compare. So this is why, for example, when you sort, you have a list of names, you can do the sort alphabetically. It's because of this. So if you have like uppercase and lowercase, sometimes you might need to change everything to lowercase because, for example, you are trying to have a list of car models, right? BMW or uppercase and then Toyota, it's going to not do it correctly. So sometimes you have to change things in order. But otherwise, you cannot figure it out. So all uppercase comes before the lowercase. And also there are also some special characters. Special characters also comes after the lowercase. So I can do it like this. For example, exclamation greater than A, true or false? As I said, no, okay. Why? Yeah. Why? Eh? Or do I need to write again? So comparison mean I is also based on the ASCII values. So I exclamation is 33. Okay, I'm wrong. So all the special characters before uppercase. Oh, number is a number. Oh, no, number, you cannot compare number. It is just a number. You can only compare the string. So string has been converted to number, but number. Okay, let's do it, right? So for example, right, we can say A, this is, for example, 63. I think the numbers are before that. Yeah, all the numbers are before, because you can only have 1, 2, 3, 4, 5, 6, 8, 9, 0, right? And then the special characters, and then the uppercase, and then the lowercase. So all the numbers will be at the beginning. No, the number, this is only 6. It doesn't matter what comes after. Yeah. Yeah, it doesn't matter. It will only count the first one. So 0 is 0, 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not sure about 10. And let's say what's the number 10 in. It's probably still 10, but I'm not sure what is it. Printable character, okay. Number 10 is the new line. So this one is number 10. It's kind of weird. So this sign represents number 10. This one here. It's confusing, but basically it's 0 to 9. And then comes after this, and then a bunch of special characters. Maybe I clean out the first 30 SCII. See if it can show you. Okay. Oh, interesting. Okay, I can do this. So I can come here. I can print it out, and we can see what's in there. Right? Ooh, one. What's this? Oh, it doesn't show up. So, oh, this is ASCII, so it doesn't. Um, letter G, 430 characters. Anyway, this is kind of weird stuff. So that's like sometimes you need to be careful when you're comparing the strings. Like I said, numbers comes first, special characters, uppercase, lowercase, and there will a bunch of other stuff like after that. And also like all the emojis, you can also convert to ASCII. So this is how you print out some of those in Python programming. Yeah, usually don't compare, except that if you want to sort the numbers, very like obvious, by last name, first name, something like that, you can do that. But otherwise, sometimes you get some weird result that you don't understand because basically you can think about everything that you use in Python. Eventually, it's just a variable, and variable is going to store somewhere in the memory, and the memory is only 0 and 1. The computer doesn't understand anything other than 0 and 1. So in order to store, they need to figure out something that how do I represent this one in the computer memory. So the number 0 will be still 0, 1 will be 1, 2 will be like 1, 1, 1, like basically 0 and 1, 0, 1, something like that. 0 is 48, whatever. Yeah, it's weird. Oh, yeah, okay, let's do this one. So let's print out. Yeah, maybe that may be the case. So let me print out 60. Oh, yeah, 56, you see here. 8, 9, and you see the text editor. Oh, yeah. Okay. Ah, okay. Okay. What else? I see. That's why it's not coming up here. Backspace, exclamation is 33, and then the parentheses, all the stuff. Oh, this is like international standard. Yeah, it's computer. Yeah. So, and then the numbers, and then, well, why I don't understand why the colon. Okay. So you can, let's do like 100. So probably you can print out all the uppercase and lowercase stuff. Yeah, basically your keyboard, everything in your keyboard is represented, right? And then equal sign, like 1, 2, 3, 4, 5, 9, and then this, A, B, C, D, E, F, G, and then up all the lowercase. So everything has a number representing this one. So it's more like coding, encoding stuff. It's weird. So let me see again. So the first 20, 30 something are all the weird stuff, more like the keyboard, keystroke. Then you have some spatial one, and then comes from the numbers, and then a few more spatial one, and uppercase, and then a few more spatial one, and then lowercase. Anyway, weird. I cannot remember, so you really use this one, except if you know to compare. Again, it doesn't matter. Only the first one. If the first one is the same, and then it goes to the next one. So here I can apply the same methods, right? I can say, how about this one? A less than B. True or false? True or false? True, right? Because the first character is the same. Then you compare the second one. A uppercase lower than B. Yes. Yeah. True. How about this one? Huh? True or false? False. Because uppercase comes before lowercase. So the first one is the same. Then you compare the second one. So lowercase b, A, and uppercase B, B is bigger. It's B is smaller. No. Yeah, B is smaller. So A smaller than B is false because this is smaller, right? So B, I don't know the character, like what's the number anyway. Weird, but this is what computer is about. And so next about the, what time is it? a couple more minutes, let's finish this one. So you can also have multiple criteria. You can have just one, and you can have greater equivalent, less than equivalent, and then in Python there's and, or, and you need to be very careful about this. So and statements means sometimes it doesn't execute all the lines. So conditional statement is going to execute from the left to the right. So take a look at this one. So A is 22, and then this is 18. So you're going to check A is greater than 21, true or false? True. If it's true, if you have an n, you need to evaluate all of them until you get the false. Otherwise, you don't know the result. But if the first one is false, then you don't need to execute the other one because the result will be false. Because n means you need to meet all the conditions. If you find the first one that doesn't meet the condition, you don't need to continue. So in here, this one is going to be greater than 21, yes. And is one greater than 21? No. Then the answer will be false. Okay. But if I'm saying, okay, greater than 23, this is totally different. Because 23 is 22 greater than 23? No. Do you need to execute this one? No. So this is where you understand like which one is executing, which one is not. This one is not executed. So it never reads any here. If you have anything wrong, it probably even it will notice. It won't notice. You can put still probably write it. You see, it works just fine. But if you reverse it, then you cannot run it because this variable doesn't exist. So if you try to, for example, print out this variable, you will get an error. You're going to say this variable is not defined. But why in here is fine? The reason for that is for the and statement, if the first one is not met, it's false, it doesn't execute the remaining. So you need to be very careful about when you have multiple statements, which one is checked, which one is not. So and means if the first one is true, you need to find all the true until you find the first false. If you already find the first false, then you don't need to run all the other stuff. So and means all of them. You can put the parentheses, or can have or. Or means similar. If the first one is true, you don't need to run all other stuff because it will be true. Because you only need to meet one requirement. So in this case, right, it's going to say A is 22 and then 18. 22 greater than 21, true or false? True, right? Doesn't care about what this is doing. I can do the same thing. I can run this one, it's true. It doesn't matter what I'm going to make something here. It will not detect that because that part is not executed. But if you reverse the other side, it's different. So make sure you understand true means and means you need to be all true in order to be true. Or means you just need one true and then it can be true. Unless you get all the false and then you will be okay. Over, right? Out of time. Yeah, we cannot finish. So then we'll continue next Monday. Probably I will record a video and then finishing this one and then go to the dictionary part so that we can finish the remaining next week. Okay. And for the lab assignment, there will be something about this. You can run through it and then you can also watch the video to finish that. Okay, so that's all for today. I will see you the next lecture.